If you look at an ellipse,
Parabolas joined together, sir.
two parabolas joined together. Mm-hmm. Can we say so? Yeah, imagination is nice, but it's actually something different. All right. See, so technically, what is an ellipse? Ellipse is you take a point, okay? Let's take any point, say P is the point, okay? An ellipse will have two fixed points. In case of a parabola, how many fixed points we had? What was the name of the fixed point called?
Directrix.
Fixed point was called as the directrix. செவுலே விடுவாங்கன்னு சொல்லுவாங்க இல்லையா அந்த மாதிரி இல்லாம that was a fixed line. The fixed point is called as what, Jonathan?
Focus.
No, focus இருக்கணும், focus. So focus is the fixed point. So here it's going to be minus a comma 0 and this is a comma 0. எங்கடா ஏதோ இதுல இருந்து ஏஞ்சி வந்த மாதிரி சொல்ற டக்குன்னு.
Okay.
So you have two. In case of a parabola, you will have only one fixed point, whereas here we have two fixed points. Okay, here. Now, so what is special in the ellipse? The distance PF1, okay, plus the distance PF2. This distance will always be the same. PF1 plus PF2, if you see, or plus PF2, let's consider another point. Choose a point here, okay? Name this point as P1. Take another point P2. So the distance, or if you calculate the distance of this point, another point from the fixed points. So what will be the sum of these? So find the sum of the lengths of the colors, same colors. Two blue colors, sum will be what? PF1 or P1F1 plus P1 Okay, so those points have their sums, the distance from the fixed points to be equal, or they will be always a constant. This distance will always be a constant. It will not change. So all the points which have this kind of relationship, when you plot a curve for such points, the path or the curve that you get is what is called as the ellipse. This is what an ellipse is. It's not a parabola, hyperbola, inverted hyperbola, circle is shrinker. No, it is the distance, the points in a plane, the sum of whose distances from two fixed points in the is always a constant. Okay, so you can choose any points. So you can choose a point P3, you can choose a point Pn. So their sums should be the same. You got it?
Yes, sir.
Yes, uncle.
Okay, so that is about what an ellipse is. Was that a question?
What's it?
No. Was there any question?
No, sir.
Okay. Let's see here. See, now we said you're going to have the focus, fix the points over here. And we don't have a vertex. Instead, we have a center of the ellipse. Okay, and this is a comma 0, and here you will have minus a comma 0. Okay, the distance between the two vertex. So here the vertex is this is going to be the vertex. The vertex. The distance between two vertices is going to be called as your major axis. The length, whichever is theta. This is your major axis. The distance of the line segment passing through the center, the distance of the line segment which is passing through the center and perpendicular to the so this is your major axis, right? The major axis is the one which passes through the center and touches the vertices,
Yes.
whereas the line which is perpendicular and to the major axis and passes through the center is known as your minor axis. Yeah.
Sir, it's major and minor, right?
Oh,
Yeah.
when did it become major axis and minor axis?
Mm.
Right. Okay. Okay. So focus, before going to the focus, the okay, that is not a so one correction here. F1 is not a comma 0 or minus a comma 0. The major axis, the length of the major axis will be 2a, which means on either side of the center, the distance is a units on both the sides.
Vertex is a minus a comma 0, sir.
Yes. So this is an A, and this side you have another A. Okay. So one of each vertex will be a comma 0 on the right side of the y-axis, and here it's going to be what did I write? A comma 0. So a comma 0 on one side and minus a comma 0 on the other side. And likewise for the minor axis, it is going to be 0 comma b and 0 comma minus b. So what will be the length of the minor axis? It would be
Two.
2b. Okay. And F1, F1 and F2. So the focus will be C comma 0. So this distance will be C units, and this distance will also be C units. So it will be minus C comma 0, and here C comma 0 will be your focus. Okay. So what will be the distance? Okay, so now let's write down, summarize all of these. So the length of the major axis will be
2A.
2a. Minor axis
2b.
2B.
2b. Distance between the foci,
2C.
Ah, yes, sir.
right? Clear?
Yes.
Yes.
Yes, sir.
Okay. All right. Now, okay. So can I erase this one
Yes,
now?
sir.
Yes, sir.
All right. Now we're going to see the so what will be the If major axis is 2a, minor axis is 2b, their lengths, what will be the length of semi-major axis?
Yes, sir.
Yes. So semi-major axis will be A. Likewise, semi-minor will be B.
B.
The distance of the focus from the center will be
C.
distance of focus from center of ellipse. It's going to be C. So now we are going to see the relationship between A, B, and C. So how they are related. Let's take a look at it. Shall we?
Yes, sir.
So what was the focus we said? C comma 0, correct? C comma 0, and this is B or 0 comma B. So this is a right angle triangle, isn't it? Inside.
Yes, sir.
Yes, sir.
O, F2, and you give some name for the semi-major axis. You give something as Q, okay? And you can even call F1 minus C comma 0. All right. Now, this length is what? B. OQ is what? OQ?
B.
B. Right? Okay. OF2 is?
C.
To C.
So what will be QF2? Hmm?
Root of B square plus C square.
Root of B square plus C square. Right? So how about on the other side? The same thing.
Same thing.
Okay. Because this is perpendicular. This major axis is, minor axis and major axis are perpendicular to one another. Now, let's choose a point. We're going to consider a point P at one of the vertex. Now, what will be the distance of the point P from the fixed point? So, what are the fixed points here? Once again,
F1 and F2.
exactly F1 and
F.
F2. PB at one end of the axis. Okay.
Yes, sir.
P lies on.
Yes, sir.
So, can you guys tell me what is the coordinate of this point?
A comma 0.
Exactly, A comma 0. So, what is the definition of the ellipse now? The sum of the
A minus C.
P F1 plus P F2 should be a constant, isn't it?
Yes, sir.
Correct?
Sir, it could be what?
Hmm?
Could you repeat that again?
The,
P1 plus P2.
so, what is an ellipse? Ellipse is nothing but Set of all the points. Set of all the points what? Whose distances from the fixed points.
Is constant.
Uh, from the sum of the distance from the two fixed points in the plane is always the same, right? Let's now try to find the value of PF1 plus PF2. So what will be your PF1? So
Root of
PF,
p square plus c square.
hmm? PF1 can be split as OF1 plus OP. Can we split it like this? Do you see what I'm saying? OF1 plus
A plus
uh,
E.
uh, A plus, isn't it?
Ah, yes, sir.
Yes, correct, right?
Yes, sir.
Two is C. Are we getting 2A now?
Yes, sir.
Yes.
Okay. Okay. Now let's take so PF1. So this is the value of PF1 plus PF2. Correct?
Yes, sir.
This is equal to what?
2
2A. Now, where does the point Q lie?
O 0 comma b.
Okay, does it lie on the ellipse?
Yes, sir.
Yes, sir.
Okay. All right. So according to the definition of the ellipse, Q 0 comma B is on another point on the ellipse at the at one end of the minor axis. Correct?
Yes, sir.
So this should also fulfill the definition of an ellipse, which is what?
2b.
Its definition is Q plus QF2. So this should be equal to PF1 plus PF2, isn't it? So let's
Yes,
try to
sir.
find the value of QF1. What is QF1 now?
Yes.
We've
Root
already
of p
calculated.
square.
Plus
Exactly.
C.
Yeah. So plus another QF2 is also the
Yes,
same
sir.
thing,
Yes.
which is what now? 2 times root
b square
3
plus.
square. Correct?
Yes, sir.
Yes,
But
uncle.
what is it equal to? This should be equal to what now, according to the definition of an ellipse? Exactly.
2A.
Exactly. Do you guys understand this part?
Yes, sir.
Both are constant.
Then only it will become an ellipse. Yeah, that is then only it will become an ellipse, isn't it? Can we square both the sides? Can we square both the sides?
A square equal to B square plus C square.
Hmm?
A square is equal to B square plus C square.
Yes, is equal to a square. Correct. Got it, guys?
Yes, sir.
Is this clear? Hmm? So the relationship between A, B, and C, the relationship is what? A square is equal to B square plus C square provided, which is your axis. A is your major axis,
Yes, sir.
right? Okay. Now we can derive so many things out of this. So if you want C from this, what will be the value of C here? C square would be, keep
A
C square
square
on one
minus
side,
B square.
minus B square, or C will be root A
A square.
square minus B
Minus
square.
B. Either.
Okay. Yeah, you say something? Okay. So these are all the relationships that we must be knowing. Okay. And hope you guys understood all the
Yes, uncle.
definitions. What is A, what is B, and what is C. Okay.
Yes, sir.
Yes.
Now we're going to see another important term. One more important term. Can I erase this one now?
Yes, sir.
Right? Okay. So we're going to see yet another important thing, which is called eccentricity. Eccentricity. What is this? Okay. So this is nothing but, so eccentricity defined by, by the symbol A, represented by the symbol E, which is nothing but ratio of the distance, ratio of the distance from the center to one of the foci is what? Ratio of center to one of the foci was what?
C.
C. To C
E by A.
by
Semi-major
A.
A.
axis.
Sorry? Yeah,
Semi-major axis.
semi-major axis. One of the vertices, distance from the center to one of the vertex is going to be A. C by A. Very, very important. Okay, it's a lot helpful for us. Or C is equal to what? C is equal to
E.
AE, A times B.
Yes.
Okay, so this ratio of the distances from the center to the foci and center to one of the vertex. Center to one of the foci and center to one of the vertex is called as what?
Eccentricity.
Eccentricity, this ratio. Okay. Okay. So what is the distance of one of the foci from center of the ellipse?
C.
Distance of one of the foci from the center of the ellipse.
C, sir.
3 units.
In terms of eccentricity.
AE.
Is equal to
A to E.
uh,
A
yeah,
to
which
E.
is AE, product of semi-major axis, or is equal to eccentricity times. They may ask you all, different things. The wordings could be different. That's all. So as long as you know what each one means, you should be fine. Okay. All right. Okay. Next, we are going to see the standard equation of an ellipse. What is the standard equation of an ellipse? to be. So before going to this, some of the யாரோட phone தான் அது? ஐயோ, காது கிழியுது எனக்கு. அதை ப்ளூடூத் போட்டுட்டு இருக்கேன். It's just hears my ears. யாருக்கு ஒரு அலர்ட் வந்ததா?
Uncle, doorbell.
Yes, sir.
Huh?
Calling.
Calling bell டா.
It was a doorbell.
ஓகே, சிரிக்காதீங்களா, காது கிழியுது. So here, so we're going to consider a few things. One is, first one, we're going to say the center of the ellipse is at the origin. Okay, is origin. Second thing, the foci are going to be on x-axis or y-axis, just like what we were seeing all this while. Okay, so now we're going to see first one, foci on the x-axis. So if the foci is along the x-axis, what will be the length of the major axis? How will your thing look like?
2A, sir.
Yes, it's going to be 2A, isn't it? So you have foci. Okay. So in this scenario, what will be our let me just zoom this a bit. F1, F2. What was F1? Minus CA0. F2 was C comma 0. Now let's choose a point P, X comma Y. All right. PF1 and PF2. Okay.
Okay, Uncle.
Now, the standard form of the equation of an ellipse whose foci is on the x-axis is going to be, okay, x square by a square plus y square by b square equals to 1. Remember this. Okay. On the other hand, if you have an ellipse, whose foci is on the y-axis, so what will be the foci here? 0 comma c and 0 comma minus c. Right? Is foci is along the y-axis. So for this thing, your equation is going to be x square by b square, because b is going to be your major axis, semi-major axis, right?
Yes, sir.
0 comma b and 0 comma minus b. So y square by a square equals to 1.
Uncle, in both of the equations, A is greater, right?
A won't be greater. Only in case of where your which one?
A is greater than B, right?
No. A, nothing like that.
Oh.
If A is greater than B, force is on the x-axis.
Hmm.
Okay.
Okay.
Yeah. Oh, switch off. What happened? Lost instant. Has the presentation come back? Okay.
Yes, sir.
Yeah. Okay. Is this one clear? Mhm. Clear, right? This one.
Yes.
Okay. So there is a derivation part. I don't know if you guys are interested. We can go for it. If not, we can skip the derivation part. Okay. Okay. So
Which
now I'm
derivation,
going for
uncle?
the derivation for this equation, x squared by a squared plus y squared. Did you guys see this in the school? Have you guys seen this? Or probably you might have, I don't know if that was skipped for you guys or was it?
Yeah.
It was skipped. Okay. So if, again, it's nothing. Okay. Pretty simple. You just have to, I'll just give you a small heads up how this is obtained. So P is any point on the ellipse. The foci is going to be on the x-axis. The center is origin. C comma C. So what will be the sum of PF1 and PF2?
2A.
It's going to be 2A. So
Yes,
what
sir.
will be the thing in this case? Distance PF1 will be what? And distance is going to be what? X plus C, right? What will be PF2? Y minus C. Y minus CL? No, just Y square. Correct?
Ah, yes, sir.
Correct? Right? So if you square it, what are you going to get? X squared plus 2xc plus c squared plus y squared is equal to 4a squared. Correct?
Yes, sir.
Yes, sir.
Yeah. So this instead of this equation, we just simply square it rather than squaring the ones on each side. So you get x plus c the whole square plus y square is equal to 4a square. Isn't it?
Yes, sir.
Yes, sir.
Okay. Now for the other side, what will be the distance? For this is for PF1. This is only for PF1 alone, correct? We have not found PF2. What is PF2? x minus c square plus y square, guys.
Yes, sir.
Yes, sir.
Okay.
So,
Mhm. So,
that,
okay.
that
Wait, wait, wait,
also,
wait, 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 wait. So we just keep one x plus c square, one square root on one side. We take the remaining to the other side. Okay.
okay.
Now square it.
X plus c the whole square plus y square is equal to 2.
Mm.
Oh, no.
Okay. So what do you get? X plus c whole square plus y square is equal to 4a
4
square
is
plus now the root square root thing gets squared up. You get
it's
x minus c
x
square plus y
minus
square. And what do you get? Minus
minus
2 into
4
2a. Yeah, 2 into 2a. That is going to be 4a into.
root of x minus c whole square plus y
Ex-
square.
Exactly. Correct? Isn't it?
Yes, sir.
Yes.
We can again square this, sir.
Yeah. No, 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 no. Why do you want to square this again?
To cancel that root.
To cancel the root out.
Yes, sir.
Just cancel these x squares, y squares. See what else
We
you
can
have.
expand
So if you
that
expand
x
this,
plus c whole square.
yes, what will you get? X square plus 2x c is equal to 4a square plus x square plus c square minus 2x c minus 4a into root this thing. Correct?
Yes, sir.
Just cancel x square c squares, 2x c.
4xc will become
Mm. So you will have 4x to c. If you take the xc minus 2xc to the left side, becomes 4xc is equal to 4a square
minus
minus 4a root x minus c the whole square plus
y square.
y square. Correct? Isn't it?
Yes, sir.
Now you take a square to the other side, or you bring this 4 into a square minus xc will be equal to what? 4a into root
X
x
minus c
minus c the whole square plus y
y.
square. So actually we are doing the derivation now. I don't know if Jonathan and Krishna are following it or lost in between.
Yes, Shankar.
Yes.
Squaring on both sides.
No squaring right now. Wait. Root x minus c the whole square plus y square. Okay. A square minus x into c by a. This a is taken to the right side. So what do you get?
A minus
C by a. Correct?
yes, sir.
So far clear?
Yes, sir.
Okay. Can we simplify this once again? Squaring both the sides. If we square both the sides, what do you get?
X
Or
minus
simply,
c.
hmm?
Equation of ellipse.
X minus c the whole square plus y square is equal to
Yes.
A minus C by A. Is equal to A square plus X square C square by A square minus what?
C.
2x
Yes,
C.
sir. 2x.
Correct? Is this clear till this place?
Yes, sir.
All of you?
Yes, uncle.
You cancel both of them. So bring x square to the other side. What do we get? X square. Okay. Plus y square is equal to. We also have. What else will we have?
C square and A square.
Hmm. We have y square. A square is here. Bring your c square this side. We have minus x square c square divided by a
Yes,
square. Okay.
yes, sir. A square minus C square is B square. Yes, sir.
Hmm.
A square minus C square is B square.
Yeah. Look, one is not. One of them is not tallying here. X square plus c square minus 2cx squared c square. If you take the LCM, what do you get here? What is by a square?
A, A square x square minus x square C square plus A square y square by A divided by A square.
Seriously? Okay. A square plus b square. No. What is a square? B square plus c square. Huh?
Yes, sir.
Yeah. So your a square minus c square will be right.
Yes, sir.
Okay. So x square minus x square c square by a square plus y square equals b square. Divide throughout by b square. What do we get? So this should be slightly modified. This is going to be, if you take LCM here for this, 1 minus
A
c
square.
square by a square, correct? Plus y square is equal to, now divide whole thing, okay, right now we'll not divide, we'll divide it in some time. Now if you take the LCM common for x, you take x square common out, what will you get here? Square into a square minus c square divided by a square plus y square
B square.
equals to b square. Okay, but what is x square minus c square? We
B
replace
square.
it with b square. So x square times b square divided by a square plus y square equal to b square. Now divide throughout with b square. What do you get?
X square by a square plus y square by b square is equal to 1.
Yes, sir.
Absolutely. So x square by a square plus y square by b square is equal to 1, which is this equation for the ellipse. Got it?
Yes, sir.
Yes, sir.
This is how you
Yes, sir.
have it. May not be required, but it's only for your understanding purpose. Okay. So tomorrow, if I skip this one in the future, when you go for higher classes, if you are deriving something, you won't be able to follow that completely. It might take some time, but that some time can be reduced by going through what we did now. That's all. Okay.
Okay, sir.
Yes, sir.
All right. Okay, guys. So this is going to be the standard equation of the ellipse. So, yeah.
Yes, sir.
And then there is one other thing, latest rectum. Probably, I think we can do it in our next class. Latest rectum, we can take it up on our Monday session whenever you guys plan. So after the latest rectum, we'll be through with the ellipse and move on to hyperbola.